Hello everyone! Welcome to this tutorial on setting up a cascaded pool. This video has been a long time coming. I know I haven't uploaded anything in a while. So, thank you for subscribing to the channel and sticking around. Your support means a lot to me. This video is almost 1 hour long, which is longer than my usual videos. I don't often create step-by-step tutorials, but for this one, I tried to include more details about the process. I've split the video into 2 parts, and this is the first one. I'll show you how to create a small single simulation and then merge it into a larger pool using the ocean surface meshing mode. Before I begin, it's worth mentioning that merging multiple ocean surfaces is a feature exclusive to 3D Studio Max. It won't work in other software like Maya or Vantage, for instance. However, I'll also share some tips and tricks for making it work outside of Max, so stay tuned for that as well. I believe this video is packed with useful information and insights, so let's not waste any more time and dive right in. Here's a clean scene where I have just this one element that I plan to use to create my pool. I have the Phoenix Liquid Simulator, a geometry object that's used as an emitter, and a Phoenix source node that uses this object. Down here I have the polygon ID set to 2. That's because here on this object, I've set this back polygon to that specific ID number, and the rest of the polygons are set to ID 1. There are also a couple of particle shaders. The first one is set to point shading mode and has the foam particles included. And the other one is set to splashes rendering mode and it has the splash particles added. I made a separate layer and moved these particle containers in it because I like to collapse it and have a cleaner layout view. For the simulator settings, inside of the dynamics rollout, I enabled the initial fill-up for the grid, set to a level of 15%. And I kept the fill-up for ocean option on. I ran this simulation starting from frame minus 50, so that I have a 50 frame pre-roll. That way the simulation starts earlier and by frame 0, it already plays how I wanted it to. As you can see, there is nothing special about this setup. It's quite simple. So let's try to recreate it from scratch. I'll create a new layer so I don't mess up the other one. And I'll pick a Phoenix Liquid Simulator from the toolbar. And I'll make one here that has roughly the same dimensions as the other one. I'll create a simple box. Turn it into an editable poly. Let me unhide the ribbon and inset this polygon at the front. I can now extrude it holding Shift. Okay. And I'll add a slice modifier. Set it to slice along the x-axis, remove the negative part, and I'll leave the cap checkbox on because I want to have a closed watertight geometry. I'll tilt the slice plane like this, maybe move it a little. And I'll collapse this to an editable poly once again. You can, of course, add some chamfer to the edges and make it look pretty, but I won't do that because I don't think it's important. What's important is that I set all of the polygons to some ID number that I won't be using for emission, and set the polygon from which I want the liquid to be emitted to a unique ID number. It can be any number. I'll stick to ID 2. Right, I'll move it up here. I made it quite large so I can scale it down a bit. And by the way, I'm not modeling this to scale. I work in a metric system with the display units set to centimeters. And 1 system unit equals 1 centimeter. I appear to have created an object nearly 70 centimeters wide, which works perfectly for me. It's neither too large nor too small, making it just right for its purpose. Of course, if you are working on a project and have some blueprints or some manufacturer specifications for this element, you can use them. I don't have any, and I do not particularly care about that in this case. Next, I'll create a Phoenix source node, and I'll add the object as an emitter. And I'll set the ID number for the emission. And I'll start the simulation to see if it's working. It seems like it works just fine. I'll stop it, and I'll now enable the initial liquid fill to put some liquid at the bottom. Remember, in the other one, I had the initial liquid fill for the grid set to 15%. I can set the same level here. The ocean fill is enabled by default. I'll leave it like that. "15% of the grid is instantly filled with water. The water level will stay the same because of the ocean fill. And by the way, if you want to see a more thorough explanation of the ocean fill and what the difference is between it and the regular fill, You can watch the other video that I recently made. It's called Initial Liquid Fill for Fountains and Rivers, and I believe it explains it fairly well. Let me open the preview settings and show the mesh for the first simulator. Perhaps hide the liquid particles so I can see the mesh better. Let's do the same for the other one. Right, you can see that the first one is much smoother than the new one. That's because in the first source, I had some noise set for the emission. I can set the same amount of noise for the second source. Now it looks too noisy and broken up. But that's because the first one is using 4 SPF, and the new one is still calculating only 1 step per frame. I can set it to 4, and the result will be smoother and not that chaotic. But at the same time, it will increase the time needed for solving each frame. So maybe I keep the SPF to 2 steps for now. That's better. Let's now enable the secondary particle emission. First, I'll switch the splash and the mist particles on. Phoenix will offer to create a particle shader. I'll say no because I plan to use one of the shaders I already have. Right away, there are some splash particles and also mist particles. The mist particles are shown as yellow dots. They spawn when a splash particle travels some distance, and the rate is controlled by the splash to mist parameter. I'll leave the parameter as it is, but I'll just set the amount to 0. Right, let me just expand the preview rollout. Hide the splash particles and do the same thing for the other simulation. And now you can see that the two meshes have slightly different shapes. The one on the left has more straight edges, and the new one looks more narrow at the bottom. That's because we have this affect liquid parameter. It is set to 1 by default, and each time a liquid particle spawns a splash particle, it gets deleted. And since we're meshing only the liquid particles, which are constantly being replaced by splash particles along the way, the mesh just gets thinner at the bottom. I can set it to 0 so that no liquid particles are being removed when they produce splashes. Actually, let me just check what I had this parameter set to in the original one. Right, it's not 0, but a small amount of 0.2. Let's use that. I also noticed that the liquid-like parameter was set to 1 in the first simulation. This will help the splashes stick together and behave similarly to the liquid particles. I'll restart the simulation because it finished while I was tweaking it. It seems like I have a lot more splash particles in the second simulation, but that's not a surprise. I'm simulating it with only 2 steps per frame, and the flow isn't as smooth as the other one. But also, I think the left one has a higher birth threshold and produces fewer splash particles. Let me use the same threshold for the right one. Threshold 12, and the amount, what was it? 5. Right, with the same SPF, I believe the look will match even more. But before I increase it, let's take care of the foam. Once again, Phoenix will offer to create a shader for the foam particles. I already have one, so no. Let me hide the mesh and the splashes so I can observe the foam better. It looks like the foam appears at the bottom, where the liquid hits the ocean surface. The foam generation threshold uses a slightly different algorithm than the one for the splashes. It is set in centimeters and measures the difference in the velocity inside each voxel compared to the velocity in its neighboring voxels. 5 foam bubbles are created inside that voxel if the difference is bigger than the threshold value. 5 is the default. The foam appears where the movement is turbulent and chaotic. If I say that the difference needs to be greater, there won't be as many voxels that meet this criteria, and in this case, there will be hardly any foam bubbles created. If you lower the threshold, saying that it is enough to have just a small difference in velocities inside the adjacent voxels, more of the voxels will spawn the number of bubbles that are set inside the amount parameter. An alternative way for generating foam is to use the foam on hit parameter. By default, Whenever a splash particle interacts with the liquid surface, it creates 0 foam particles. But if you increase that parameter, let's say, to 1, one foam bubble will spawn inside the voxel, where the splashes touch the water. Since I lowered the affect liquid parameter, and there are more liquid particles and splash particles sharing the same voxels, there are more voxels that meet the foam by hit criteria, and the foam appears even up here where the water flows down. If that's what you want, then great. You can even spawn more foam bubbles inside these voxels. I don't need that, so I'll leave this at 0. Right, what else? Seems like the foam lives for too long on the surface. The bubble's lifespan is controlled by the half-life parameter. The value is in seconds, so I can set it to half a second. My project is set to 25 FPS, so half a second is about 12 frames. Let me restart the sim. And the half-life, where was it? Not this one. There it is. The half-life parameter, as I said, affects only the foam that is on the surface. Perhaps I can lower it even more. Maybe 0.2. That'll be 5 frames. Right, I'll think we're getting there. Seems like in the simulation on the left, some patterns are appearing. In nature, these are caused by the upward motion of the fluid, which pushes the foam away, creating these circular shapes. You can reinforce this effect by increasing the pattern formation speed. I'll set it to 0.5. And I guess I can make the pattern radius a bit smaller. Right, let me hide the mesh from the viewport, show the liquid particles. And I think I'm ready to increase the SPF now and start a test sim one more time. Let me actually check the amount of foam that is being created by the first simulation. It's 10. I don't think I have that many in the new one. Right, it spawns only 5. Let me double that. The threshold is the same. Let's just wait for a few more frames to see how this is going. I think the foam disappears too quickly, though. Let me check the foam lifespan in the first sim. Ah, yes, it's a little bit longer. Let's use the same value for the new one as well. Okay, I think that's enough tweaking. Let me adjust the start frame to -50 and simulate the entire sequence. It will look like it isn't doing anything at first, but it actually calculates these initial 50 frames. Once it is ready, the timeline will start updating, and you'll be able to see the progress in the viewport. Right, I can keep tweaking this, but for the purpose of this tutorial, I think that's more than enough. Let's not waste any more time and go back to what this video is actually all about. And what it is about is merging these two simulations into one continuous surface. It's actually pretty easy to do that. It happens automatically just by changing the meshing mode in both of the grids to ocean mesh. All right, let's go ahead and try this. I'll go into the rendering rollout and change the meshing mode from a regular mesh to ocean mesh. I'll do the same thing for the second simulation. Because this is the first time I'm doing this for the new sim, Phoenix will display a message that says that it is strongly recommended that this object is rendered as a V-Ray static geometry, and it'll ask me if I want it to change it for me. Dynamic and static mesh refers to how V-Ray handles the memory during rendering. I'll click yes. Let's run a test render. I'll leave it at half resolution. When I press render, Phoenix will display another message to inform us that there are multiple containers that are using the ocean mesh mode, and they will be merged. The merged surfaces, material, and displacement settings will be taken from the small Waterfall 001. This is the first Phoenix container created inside this scene. I'll press OK. And there's the merged surface. You can see that there's a problem here. I set the fill-up level inside the second container to 15%, but didn't change the procedural ocean surface level. The ocean level is still at its default 50%. I'll set it to match the fill-up level. I can render this again, and again it will inform me that the first container will be used to get the material and the displacement from it. I'll click OK, and the second container's ocean surface now matches the liquid fill-up level. However, it also merges with the ocean surface generated by the first container, and you can see that the left one sits slightly lower than the right one. This is because I deliberately made the second one slightly higher, and 15% of the higher container is higher than the 15% of the other one. I did that because I wanted to show you that you have to have this in mind when setting your simulations. I can move the right container down a few centimeters and try to match the surface level. I'll just switch to the left view and create a line here. And let me first parent the emitter object to the simulation container so that I can move them together. I can now move the container down, try to eyeball the position it needs to go, and try to match both levels. Let's see if that's enough. I'll render it again. I need to move it a bit further down. Let me try minus 1.5 centimeters. Yep, that's better. But as you can see, here's the surface where the simulation is. It blends with the procedural ocean surface that extends beyond the container box. However, the transition could be smoother. So I can go into the rendering rollout and increase the border fade parameter to, let's say, 25%. I believe I have the same value in the first container. Yep, that's right. Okay, let's make another render and see if the transition between the simulation and the extended ocean surface will be less noticeable. Yes, it looks a lot nicer now. So yeah, you need to be aware that if you have containers with different heights, even though they use the same ocean level percentage, the actual level will be different and there will be visible seams. You'll need to move them up or down and match the levels by hand. Actually, there might be a better way to get some visual reference instead of creating a line like I did a minute ago. Let me enable the mesh preview so I can see the surface in the viewport. I'll do the same thing for the other container. In the viewport, you won't see them as one combined surface, but as two separate meshes. The merge happens at render time when the actual full-resolution surface is created. In the viewport, you only see a low-res preview, and you can also see that they are misaligned. You can go into the side view again and bring them closer together. And yes, at minus 1.5 centimeters for the taller container, they are pretty close. Or let me undo that. Perhaps you can do that from the perspective view. You can change the color of one of the objects and start moving one of them until you see that they overlap. As we already know, this happens at around minus 1.5 centimeters when moving the higher one. Let's start a render and double check. Right, I can't see any visible seams. Moving the objects is only necessary when you have containers of different heights, but at the same surface level. You can, of course, adjust the initial fill in the ocean surface levels to be lower for the taller ones or higher for the shorter ones, but that might make it slightly harder to pinpoint the exact values. And of course, the easiest and safest way to achieve that is to have them at the same height and similar resolutions. So I will set the one that I made taller to 90 centimeters high, the same height as the other one. For this, however, I'll need to resimulate. In the second part of this video, I'll show you how to avoid all this hustle using a cascaded setup. Let me now talk a little bit about how to change the container from which the material and the displacement settings will be read. Let's first wait for the pre-roll to finish and make another render to check if the surfaces match, just to make sure. Looks good. Right, the simulation finished in about 7 minutes. Let me render it again and double check the surface. Looks all right. Okay, let me now talk about the materials and the displacement. I know the first simulator's displacement settings will be used, so I need to add the map to it. I'll open the material editor, where I have prepared a Phoenix ocean map. It opened on my other monitor. I'll switch to it in a second. First, I'll open the rendering rollout. Enable the displacement, and plug the ocean map into the displacement texture slot. I'll render full resolution this time. And there it is. The displacement is applied to the entire surface. Perfect. Let me close that window and move on. Okay, so I'll make a few more Phoenix containers by copying the second one, just so we have more containers to work with. And by the way, let me bring your attention to this small detail. Here's what the output path looks like before I make the copies. This macro points to a location where your scene is saved and creates a subfolder where it writes the cache files. The files' names are the same as the name of the simulation container. There are 4 digits for the frame numbers, and by default, it outputs the cache files in Aura format. If I shift-drag the simulation, I can make a copy. Phoenix will automatically change the default path for both copies to a different combination of macros and the file name that is explicitly written at the end. This new path will point to the exact same location as before, but will make sure that both these containers will read the same cache sequence, even though they have different names. If you want to learn more about this and how to control your output paths and the location where your cache sequences are stored, you can watch another video that I previously made. It's called Mastering Output Macros. Okay, let me rotate this copy. Maybe move it right here. Make another copy. Rotate this one as well. Right, something like this. And let's render this to see what it looks like. Again, the settings will be read from the first grid. Fine. Right now, all 4 of them are meshed as one. There's the displacement. Everything seems in order. If I want to apply some material now, I must apply it to the first container. I think that by now this has become clear. Just for demonstration purposes, I'll apply different materials to the other grids as well. The first copy will get the red material, the second copy will get the green material, and the third will get the blue material. Despite that, they will all use the gray material applied to the first grid. Right, if I hide this first grid though, Phoenix will automatically choose the second one and will use its materials and displacement. That's the one that has the red material applied. Also, the displacement setting isn't enabled for this one, and the surface is now flat. If I unhide the original, Phoenix will return to using it instead of the second one. That's pretty cool, but what if I want to manually switch to a specific simulation and use its settings for the merged surface? Let's say that I want to use this one, the one called 002 that has the green material. There is a parameter that can be changed that will force Phoenix to use it instead of the other one. This parameter is called ocean priority, but unfortunately, you won't find it exposed anywhere in the UI. However, you can still access it via Max script. You can press F11 and open the listener window. Here you can type the name of the property, ocean priority. And to execute this over the selected Phoenix grid, you need to type $, which specifies the current viewport selection. Put a dot between the selection sign and the property name, and say, this equals, I don't know, some random high enough number, 10 or 50. Doesn't matter. Just press enter to execute that command. If there is no error, the new value for that property will be displayed. If I render this now, Phoenix will now use the simulator with the highest priority to build the surface from. Right. 002 is the one with the green material. Let's try this with the third one. Select it and give it an even higher ocean priority. Maybe 60. Now that's the one that will be used to build the surface for the rest of them. Let me set this one back to 0. And actually, let me reset all of them to 0. Now, Phoenix will pick one for me again. It usually picks the first one that is created invisible. But again, if you want to have control over which one is used, just set the ocean priority using this simple command. Okay, you can have as many simulation containers as you want. You can move them around, rotate them, and maybe I don't want to see this message anymore. So I can click on the Don't Show This Message checkbox. Okay. And if I didn't move them up and down, the surface will be smooth and there won't be any seams. And of course, currently I have the original simulation and I made another slightly different one. But then I have two more copies that are exactly the same. Not that you can tell looking at them from a different angle, but still. You can randomize the starting position on the timeline. That's another reason why I calculated this 50-frame pre-roll. I can go into the input rollout, uncheck the auto origin, and randomize the starting frame. Pick another random timeline origin for the other copy. And now, the fact that they are the same will be even harder to notice. You can get away with a single simulation like I did in my original scene. So right now, the ocean surface is generated and extends all the way to the horizon. Because, that's what oceans do, huh? But let's see how we can cut away the part of the surface that we don't need. This surface, as I mentioned before, is generated during render time, and regular editing tools or cutter geometry won't work. I need something to cut it during the render. In other words, I need something like the V-Ray Clipper, which does precisely that. Let's create one. Maybe. Yep, there it is. I can click in the viewport. It seems like the active layer is hidden. Let's activate this one and try that again. Cool, so the V-Ray Clipper will clip everything in the direction of this arrow. Let me move it here. Right, so everything that is on that side of the plane will be clipped. That is very cool, but what's even cooler is that you can use a mesh geometry instead of a simple plane. Let me create a cylinder. Yeah, let's use that. Move it down a little bit. It might need a few more segments. Okay, and now if you select the clipper, you can enable the mesh mode option. Just pick the cylinder, and now the mesh will be the clipper. By default, it will clip everything that's inside the object. Yep, that's right. It didn't clip the particle shaders, though. But if you need to do that, you can use a cutter geometry in the particle shader options. In this case, I don't need to do that. I need to reverse the direction in which the clipper is working, and I can do that by changing the operation from subtraction to intersection. The clipper geometry may be distracting and clutters the viewport. I'll move it into another layer. Freeze it so I don't move it by accident, and I'll set it to be displayed as a box. That way, I don't have to worry about it anymore. And let's add another element. I'll get one of these grids and copy it over here. Perhaps it would be better to set up one from scratch, but this video is already too long, so I'll use the settings from one of the grids I already have. I'll just reset the path because I want to write another simulation sequence. Right, so now it is empty. I'll change its dimensions. 90 by 90 voxels might be good. I'll keep the same height, because I want to use the same level of the ocean fill. And I'll make a cylinder. Right, turn it into an editable poly, select all of the faces. Set them to ID1, And the one on the top will be ID2. Maybe I need to scale it down a bit. I'll make a new Phoenix source. Pick the cylinder as an emitter. Set the ID for the emission to ID2. And here inside the grid rollout, I can enable the adaptive grid. It will adapt to the liquid particles. And I can limit the expansion on the -z axis. And you know what? Let's limit all of them. Set them to 0. It is actually not a great idea to have an adaptive grid that expands horizontally when using the ocean fill. I'll leave only the +z axis at its default 100 voxels. That's how many voxels the container will be allowed to expand. Let me start the sim. Oh, it will do the pre-roll. I could have disabled that, but it'll be done in a second, so I'll wait for it. Right, I hope that this would look more like a fountain, but the emission force isn't very high. I'll stop it and delete the caches. I'll switch the pre-roll off for now. And I'll increase the outgoing velocity for that emitter. Let's try 200. Maybe even more. Oh, that might be too much. 300 maybe? Actually, this emitter could be a bit smaller. I just need to be careful and not make the top face smaller than 1 voxel. Let's try that again with a higher outgoing velocity. Okay, the grid will adapt and grow. Right, this looks good enough. Maybe now's a good time to add the rest of the secondary particle nodes into the shaders. There they are. It seems like the last simulation created its particles in the active layer. I'll move them down here with the rest of them. Okay. I'll select the foam shader, select Add, and pick all of the foam particles one by one. Let me check how this looks. I'll hide the simulators and start a render. Cool, looks like I've collected all of the foam nodes. Looks like I have some foam bubbles here on top of the fountain. That's fine. Let's do the same thing for the splash particles. This time, instead of picking them one at a time, I can press the Add button and then press the Select by Name button. Or I can use the keyboard shortcut, which is H. For some reason, I need to toggle the Display Hidden Objects. I can now pick all of the splash particles. Right? I can unhide the simulation grids again. I kept them all at the same height, so there shouldn't be any issues. Everything looks fine. I can now use this water material. Assign it to the simulator that Phoenix picked as the one with the highest ocean priority. Looks fine. The shaders are using all of their default settings. The one for the foam is set to render the foam bubbles as points, and the one for the splash particles is set to render them as splashes. They do appear a little bright, though. I can lower the diffuse multiplier for both of them to half. Yeah, it looks better that way. Keep in mind that I don't have a camera in this scene and I'm rendering without motion blur. By the way, when you are applying a refractive material, it is always a good idea to have some geometry behind it, something that will be actually refracted. Otherwise, the rays return a black color and the water will look very dark, like in this case. In a second, I'll open the original scene and walk you through it. Here's the original scene. Here I have the V-Ray clipper. It is frozen, so I won't select it by accident, and it is set to display as box. It uses a geometry object, which is just the inner walls of the pool, which are duplicated and scaled up on the Z-axis. And here's the pool geometry. It is in the assets layer. The model has a terrible sloppy topology and no proper UVs. I did this in a hurry. I just wanted to place something beneath the water's surface. These steps are just a few boxes. The reason why I didn't spend much time creating a proper pool model is that I set all of these objects so they are not visible to the camera. Let me enable this temporarily and render it so I can show you what it looks like. There it is. This is how it looks. The material is a multi-sub-object material with two IDs. ID 2 has a pure black material applied. Those are the outer walls that are not being rendered anyway. I used one of the Chaos Cosmos materials for the inner faces with some tiles texture and tri-planar UVs applied. Right, really simple. Let me switch them back to not visible by camera. Now they are not rendered at all. But if I unhide my simulations and start another render, although they won't be directly visible by the camera, you'll be able to see them refracted by the water surface. But of course, when you are working on your project, you will have a beautifully modeled pool you want to see in the render, so you won't have to do any of that. I only did this because I wanted a quick way to have some tiles visible through the water. As for the Phoenix simulations, everything related to them is in a separate layer. Here's my original simulation. Oops, sorry about that. Let me freeze these objects so I don't select them by accident again. Okay, so here's the first simulation. In the dynamics rollout, I have the initial fill at 15%. The fill up for ocean is enabled. The splash mist particles are enabled as well as the foam particles. The settings might be slightly different, but this is, of course, a matter of minor tweaks. There's nothing that much different from the scene that we were looking at a moment ago. And finally, inside the rendering rollout, the ocean mesh is enabled. So is the displacement. And a Phoenix ocean map has been applied. Here are the settings for this particular ocean map. I've played with the size, set the level of detail to 6, and slowed down the rate of change slightly. The other simulations are just copies of the first one using the same cached sequence. They don't have the displacement enabled. The first one, the original, has the water material applied. Speaking about the water material, it's just a standard V-Ray material. I use the default water preset that comes with V-Ray. It simply sets the refraction to a pure white color. And the reflection it's not white, but almost white. It's a bright gray color. The only thing that I changed from the preset is the fog color. I've set it to a light blue color and set the depth to 80 centimeters. Right, let me copy the fog color from the first one. It appears to have a slightly more green tint. The most significant change I've made is switching the affect shadow checkbox off. This is necessary if you want to enable the caustics. If you don't switch that off, even though the caustics rendering is enabled, they won't be calculated for this material. Let me get rid of this and use the one that I already have. I'll switch the affect shadows back on for a second. Start a render. And indeed, no caustics are being rendered that way. Even though they are enabled inside the V-Ray's GI tab. By the way, these are the default settings for the caustics. I didn't change anything here. But the affect shadows need to be turned off for them to be rendered. When you are using a V-Ray sun, the sun's photon emit radius is another important thing to keep in mind. Let me unhide the sun. Right, so the photon emit radius must be big enough to cover the entire scene, or at least the water geometry. If it isn't, the caustics will be calculated only inside this area. So most likely you'll need to increase the radius. I don't think the default radius is big enough. Something like this should be enough. All right, what else? Let me switch the environment assets to be displayed as boxes and go back to the simulations. Here's the source that I use for that one simulation. The box used as an emitter. I place the other copies of this box into the assets layer. Let me switch the display states to be controlled by the layer so I can toggle them more easily. Okay, so these copies are what I use for the render. I usually keep the Phoenix emitter objects and any colliders that I might have as non-renderable objects. It doesn't matter that much in this case, but for more complex scenes, I rarely keep the renderable assets to interact with the simulations. I make copies, and oftentimes I modify them. It is a good habit, and for more complex scenes, it usually pays off. This allows you to easily turn off all of the geometry that might potentially cause some issues. Right, so the ones that are being rendered have the materials applied. The one used as an emitter doesn't have a material. Okay, what else? Here are the two particle shaders and the Phoenix particle nodes. I am going to upload the scene and I'll leave a link in the description so that you can get it and explore it in detail. Right, let's see what else. The simulation grids are about 14 million voxels, which, to be honest, might be a bit too much. The simulation made about 2 million liquid particles, around 7,000 foam bubbles, 6,000 splashes. There's no mist and no wet map particles. All of the grid copies are pointing to the same simulation file sequence. And you can, of course, clear the output for the copies, since you are not going to simulate them, and switch them to read the output of the first one. And you might be wondering what this window might be. It's a custom tool that I have been working on for the past few months. It is a path manager tool that allows you to review and edit the input and output paths for multiple simulations at once, among other things. I'll make a dedicated video about it, explaining its features. Once I decide that it is ready and works properly, I'll make it available so that everyone can use it. That's, of course, if they want to. Right, I have a random timeline origin for each copy to avoid repetition. And here's another tool that can help you randomize the timeline offset for multiple simulation grids. This one is part of the same extended tool set that I'm working on. In the second part of this video, I'll show how it can also be used to randomize cascaded simulations. And while I'm at it, let me show you another tool that can help you manage the preview settings for multiple simulation grids. For example, I can unhide the liquid particles for all of them, hide the grid box, and you can also decrease the number of particles displayed in the viewport. The max viewport might have a hard time drawing all of the particles of multiple simulations, so you can reduce the amount that is shown. You can do this in the preview rollout for each simulation, but the tool allows you to do that all at once. Okay, enough about that. As I said, I'll make a dedicated video about these tools. If you want to be updated, you can, of course, subscribe to this channel if you haven't already, and click the notification icon. Right, as you can see, this method works great for this type of scenes. You can quickly and easily build a large scene using only one single small element. And there is nothing stopping you from adding additional elements if you want to. Like this inflatable pool toy, which is a simulation on its own. You can keep adding elements or keep working on each one of them individually without the need to resimulate the entire scene. However, this method also has its limitations. The most important one, as I mentioned at the beginning, is that the automatic merging of the ocean surface will only work inside Max. This feature isn't implemented in Maya. Also, the procedural ocean surface will not be generated if you send this scene to Vantage. In addition, the V-Ray clipper only works with V-Ray. If you are using Corona, you'll have to use its respective clipper tool. In Corona, there's a slicer material that can be applied over any geometry, and it will work in a similar way. As of the latest Chaos Vantage update, the mesh clippers will also work there. But as I mentioned, merging multiple oceans isn't supported. It is a slow process, and as you know, Vantage is built with speed and interactivity in mind. For that reason, this setup needs to be modified slightly if you want to render it in Vantage. The last thing is that for the ocean surface to be properly generated in Max, the simulation grids shouldn't overlap. You have to keep them separated and leave enough space where the stitch will happen. This, however, means that the simulations won't interact with each other. Not only because they are the same simulation, but also because even if you make separate, unique sims, there won't be any ripples interacting with the ripples inside the other one. And also there won't be any foam colliding and merging with the foam from the sim that is next to it. In the next video, I'll show you how to make a cascaded simulation. This might be useful if you want to have optimized grids with different heights, but at the same time maintain a consistent water level for the pool. It might also be useful if you want to have these waterfalls closer together and not worry about the space between them. Make them pour into the same ocean container at the bottom so that you can have interacting ripples and foam. Using this method will also make it possible to collect all of the copies into one single pool, something that can be used in Maya. And it could also be used in Vantage. So thank you for watching. Stay tuned, be safe, and goodbye.